Hello students. The previous class we have discussed some introduction to digital signal processing, introduction to signals. Already we have discussed what is signal and how you represent the signals by means of there are four representation like your graphical representation, functional representation, tabular representation and sequence representation. Already I told you signal is a physical quantity that varies with time, space and with any other independent variable or variables. Signal itself carries some information for observation. So, as far as discrete time signal is concerned, uh, some elementary discrete time signals. Now we will discuss what is elementary discrete time signals. Even though we have already I told you what is signal, how will you represent the signal by means of four representation. There are some basic signals which play great important role in signal processing and communications. So, these basic signals are like your unit sample sequence or unit impulse sequence and your ramp sequence, sinusoidal sequence and exponential sequence. These are some basic signals which are great role in communication system and signal processing. So, now today the first basic signals like your unit sample sequence or unit impulse sequence. So, unit sample sequence, unit sample sequence, unit sample sequence, or we may say unit impulse sequence, unit impulse sequence, unit sample sequence or unit impulse sequence. So, what is unit sample sequence? So, in unit sample sequence, that is your in graphical representation of the discrete time signals. The graphical representation of unit sample sequence or unit impulse sequence can be represented as like this. Like I can say in graphical representation of unit sample sequence or unit impulse sequence like this, that is for n equal to here n equal to 0, okay, and this is nothing but your del of n or unit impulse sequence or unit sample sequence can be mathematically we can describe it by del of n Dirac delta function, or we can say it is unit sample sequence or unit impulse sequence. So, how will you represent by functional, as far as functional representation is concerned for unit sample sequence? So, you can write del of n equal to 1 or n equal to 0. So, this signal exists for n equal to 0, and this is your this x axis you can represent for any value of n like 1, 2, 3, 4 etc. This is left side of the from any that is your n equal to -1, -2, -3, but the function exists at n equal to 0. So, del of n equal to 1, that means the magnitude is 1 here, this is 1. So, unit sample sequence or unit impulse sequence, that signal exists at n equal to 0. In functionally I can represent del of n equal 1, del of n equal 1 or n equal to 0 and 0 elsewhere. So, how will you represent this signal, that is important as far as mathematical representation or functional representation or graphical representation. So, here unit sample sequence or unit impulse sequence, the signal exists at n equal to 0. So, there are some properties of delta function, or there are some properties of the unit impulse sequence or unit sample sequence. So, one of the properties, it has some properties. First property, that is your what? So, del of n, I can say del of n equal to u of n minus u of n minus 1. It is very, very important. So, we can express impulse function in terms of unit step functions. This is your u of n is your step sequence, and the signal is exist for n greater than equal to 0. For n greater than equal to 0, this function exists. So, I will tell you later. After that, I will tell you what is unit step function, unit step sequence, and del of n, I can represent del of n in terms of unit step sequence. So, one of the properties of important properties of the delta function, that is your del of n equal to u of n minus u of n minus 1. So another property is your what? Another property, if here there is your summation n equal to minus infinite to infinite, if any function, so I can say that is your del of n minus n0 into x of n, del of n minus n0 into x of n. Here x of n is a function. If it is multiplied, that is a shifted impulse function, that is your del of n minus n0, the value will be how much? The value will be your x of n0. It is very, very important. These two property is very, very important. So any function is multiplied with, we can represent any signal in terms of unit sample sequence or unit impulse sequence. So if there is a function signal x of n, if they are multiplied with a shifted impulse function, and the function can be, that is your del of n minus n0, that means the impulse function exists at n equal to n0. So that's why the value will be how much? The value of x of n0. For example, if I will say that is your if there is a summation n equal to minus 2 to 2, n equal to minus 2 to 2, suppose the function is your n square minus 2n whole into del of n minus 1, the value is how much? First of all, we will say the limit is what? Minus 2 to 2, the minus 2 to 2 here, that is your 0, this is 1, this is 2, and this is your 3, and this is your minus 1, and this is your minus 2. First of all, you will identify the function that must be exist in between this limit, then only we can apply the shifted impulse function. That means that if n square minus 2n, the function should lie between this limit minus 2 to 2. If this function lie between minus 2 to 2 and it is multiplied with the del of n minus 1, if there is a shifted impulse function and it is exist at n equal to 1, so directly I can put that is your n square minus 2n for what? N equal to 1. So that means already I told you, if in a second property del of n minus n0 into x of n is how much? X of n0. N minus n0 equal to 0, the value of n equal to n0. That's why in place of n you can put n0. Here in this example, this is your x of n and this is your del of n minus 1, and the impulse function exists at n equal to 1. That's why I can put in place of n, I can put n equal to 1. So that's why n square minus 2n, and value if n equal to 1, the value will be how much? 1 square minus 2 into 1, that is your 2, that is your 1 square equal to 1, 1 minus 2, that is your minus 1. And this whole result is nothing but what? That is your minus 1. So here it is a very important properties of the unit sample sequence or unit impulse sequence, and we can in a digital signal processing, so any elementary signals, so any discrete signals we can represent in terms of impulse unit impulse sequence or unit sample sequence. So this is one of the property of impulse sequence or unit sample sequence. So another first property is your del of n equal to u of n minus u of n minus 1. So I will tell you how it will come u of n minus u of n minus 1. U of n is your nothing but your unit step sequence, and we can express impulse sequence in terms of what? That is your unit step sequence. This is one of the basic signals in your digital signal processing, which we will familiar with. Any discrete signals we can represent in terms of unit sample sequence or unit impulse sequence. So second basic signals, that is your what? That is your in your another basic signals number 2, that is your unit step sequence. Unit step sequence. Unit step sequence. What is unit step sequence? In continuous time signal u of t, in continuous time signal u of t, the u of t equal to 1 for t greater than equal to 0. So that is your, this is your in a as far as continuous time signal is concerned, and this is your unit step sequence, unit step signals. The unit step, that is your t greater than equal to 0, this function is exist and the value is 1 here. If that is your t, and this is nothing but is your what? That is your u of t. So u of t equal to 1 for t greater than equal to 0 and 0 elsewhere, 0 elsewhere. So that is u of t value is 1 as far as continuous time signal is concerned. T greater than equal to 0, this function is exist, otherwise the function will not exist in unit step signal as far as continuous time signal is concerned. As far as discrete signal is concerned, as far as discrete signal is concerned, So we can represent graphically. Unit step sequence can be written as what? That is your the value u of n. That is your 0 here. This is 1, and this is 2. This is your 3. This is your 4. This is your 5. And x-axis is nothing but your n. So and y-axis is nothing but what? That is your u of n. And the value is what? For n equal to 1, 0, n equal to 0, that is 1, n equal to 1 is 1, n equal to 2, u of n equal to 1, n equal to 3, u of 3 equal to 1, n equal to 4, u of 4 that is 1, like this. And this value is nothing but is 1 here, dot dot. This is the graphical representation of unit step sequence. So in functionally, how will you represent the unit step sequence? So in mathematically, we can write u of n equal to 1 for n greater than equal to 0 and equal to 0 elsewhere. So this is nothing but is your what? That is your unit step sequence, or we can represent by in a discrete time signals. And if x-axis is your n and y-axis is your u of n, and the value, the function exists for n greater than equal to 0. That means for n equal to 0, u of 0 that is 1. For n equal to 1, u of 1 that is 1. For n equal to 2, u of 2 that is 1, like this. Up to infinity, the value is 1. Any values of n for n greater than equal to 0, for a positive value of n, you will found u of that value will be 1. This is nothing but your unit step sequence, or nothing but or unit step sequence. In previous case here, so in a unit sample sequence or unit impulse sequence, so del of n, how del of n becomes u of n minus u of n minus 1. We know u of n and u of n minus 1. If u of n minus u of n minus 1, how it becomes del of n? So now here, that is your u of n. Now we have to see how del of n equal to u of n minus u of n minus 1. So here now suppose if I will plot the signals n suppose minus 2, minus 1, that is your 0, 1, 2, 3, like this, and I can say this is your u of n. So tell me, this is your here u of n. For any values of n, for positive value of n, the value is 1. For n equal to 0, the value is 1. N equal to 1, the value is 1, like this. So u of n, I can in a tabular representation, I can write u of n value is what? For n equal to 0, u of 0 that is 1. U of n equal to 1, u of 1 that is 1. 2 also 1, 3 is also 1, 4 is 1, up to infinity. So u of n, the value of u of n equal to 1 for n greater than equal to 0. That's why for n equal to 0, u of 0 that is 1. For n equal to 1, u of 1 that is 1. For n equal to 2, u of 2 that is 1. Up to infinity, for positive values of n, the value must be 1. That is your u of n. Then u of n minus 1. This is your shifted step sequence. What is shifted step sequence? U of n minus 1. N minus 1 means what? N minus 1 equal to 0, n equal to 1. That means in a continuous time signal, if I will say in continuous time signal, we are using t, but in the discrete signals we are frequently using n. N is a discrete, here t is for continuous. Here t is your continuous. In a continuous time signal, how will you represent u of t minus 1? U of t minus 1. So that is your t minus 1 equal to 0, that is this is 1, the function exists like this. This is nothing but u of t minus 1. So here u of t minus 1 equal to 1 for t greater than equal to 1. The function exists for t greater than equal to 1. That is your what? U of t minus 1, and equal to 0 elsewhere. This is your shifted step signal. As far as the discrete time signal is concerned, that's why if I will say u of n minus 1, that means the function exists for n greater than equal to 1. If I will say u of n minus 1 is like this. U of n minus 1, I can say here, this is your 0, the function exists at n equal to 1. So n equal to 1, here n equal to 1, here n, this is your 1, 2, and this is your 3, like this. This is nothing but what? This is nothing but 1. The function exists at here like this. This is nothing but I can represent functional representation u of n minus 1 equal to 1 for n greater than equal to 1 and equal to 0 elsewhere. Okay, so this is nothing but u of n minus 1, this is nothing but u of n minus 1. These two are graphical representation. These are the graphical representation of what? One is u of n, this is nothing but your u of n, and this is nothing but your u of n minus 1. You will subtract this u of n minus u of n minus 1, you will get an impulse sequence or unit sample sequence. How? So here this is a tabular representation. This is your u of n minus 2 minus 1 0 like this. For that function is exist for n greater than equal to 0 like this. U of n minus 1, similarly u of n minus 1, the value is exist for what? N equal to 1 to infinity. That is, this is 1, this is 1, this is 1, this is 1 like this. If you add this, if you add two signals, that is your what? U of n minus u of n minus 1, u of n minus u of n minus 1, this minus this. If it this minus this, if it is minus, this will be minus, this will be minus, this will be minus, this will be minus like this. If you add to this, that will be cancel out. This all are cancel out, and you will get what? That is your what? You will get the function exists at n equal to 0. That's why the del of n equal to what? U of n minus u of n minus 1. This is your u of n, and this is your u of n minus 1. If u of n minus u of n minus 1, that's why if it is minus u of n minus 1, the value is like this. If you add this u of n plus u of n minus plus of minus of u of n minus 1, you will get only 1. This is nothing but what? Unit sample sequence or unit impulse sequence. So that's why we will express impulse sequence in terms of unit step sequence. Okay. So next, that is your one already I told you what is your unit sample sequence, and second one is your what? That is your unit step sequence. And number 3, another basic signals or elementary signals are what? That is your exponential sequence. Exponential sequence. Exponential sequence. Exponential sequence. Exponential sequence. So the discrete time signal x of n, the discrete time signal, x of n can be represented as x of n equal to a to the power n for all values of n exponential sequence. So a is a scalar, a is in any value which may be greater than 0 or less than 0 or greater than 1 or less than 1 like this. In exponential sequence, the discrete time signal x of n can be represented as this, as far as your functional representation is concerned. If I will say in graphical representation of a exponential sequence, in a graphical representation of a exponential sequence, x-axis already I told you, that is for n, let this is 1, this is your 0, 1, 2, 3, like this, this is your 5, this is your 6, like this. Okay, and for a decreasing function, suppose this amplitude, let this is your 4, and this is your let 3, this is your let 2, this is your 1, and this like this. This decreasing function shows that is for what? A, the value of a greater than 0, less than 1. Okay, in exponential sequence, either exponential rise or exponential decay. For exponential decay, for n equal to 0, the value is maximum, and as far as n increasing, the value is decreasing. and this is your one of the exponential sequence. If exponential rise, for exponential rise, like this. For exponential rise, this is your exponential rise. For exponential rise, this is nothing but your exponential rise. In exponential rise, this is your 0, 0, and for x-axis for a discrete signal 0, 1, 2, 3, 4, 5, 6, dot dot, and any value, the amplitude value is like this, and the value and this function is a greater than 1 here. So according to the value of a, the function shows whether the maybe do exponential rise or exponential decay. This is one of the basic signals as the exponential sequence. So I told you in a discrete time signal x of n can be represented as what? X of n equal to a to the power n for all values of n. Here a is the any value which lies may be greater than 0, less than 1. This is your exponential decay, and here exponential rise a greater than equal to 1, a greater than 1.